I'm going to be presenting most of the data today. I have a few opening remarks before I pass on the introduction mic to Bryn and Katie. So I'm gonna pick up where Bryn left off last year with the SRC. I'm gonna be presenting some of the updated trends. I'll also try to address some of the questions that were raised last year. And we seek to obtain feedback on our long-term plan to answer questions which are still relevant to the program while creating opportunities for further collaborations. And like all previous SRCs, the format of this meeting is open discussion. So if you have any burning questions after every set of data that I present, please unmute, ask your questions, or write them in the chat. But I do want to point out that there is time built in for discussion in the agenda. If I don't ramble much and stick to those times, we'll have plenty of time to discuss. So if your questions are more bigger picture and can be discussed better in the entirety of the program, that kind of sense, we can hold off because there's a slide in the presentation where I have listed all our discussion questions. I'm looking at my notes because, as Bryn will tell you, I ramble and can go unhinged. So in the preparation for this SRC, I sent out a slide deck to the SRC members, and I hope that gave you an idea about what we are going to present today, what are the updated trends, what questions we are thinking about. And I would reiterate that our goal here, one of our primary goals here for this presentation, is to get us all thinking about SPoT in a bigger picture sense. And I know SPoT has been adaptive over the years, it has changed, and we are at a point in the timeline of this program where we are sitting on so much data and we are seeking input about how these data are being used, what analytes are of concern at what sites, and how we can prioritize our analyses given our relatively fixed budget. And I will finally say this, that because I'm running this meeting for the first time and presenting these data, I want to make sure that I say that there are going to be a lot of questions that we are going to answer as a group today, but there will definitely be questions which need follow-up. So please feel free to reach out to me and I'll follow up about any questions that remain unaddressed and needs follow-up. With that, I will pass the mic on to Bryn Phillips.
Hi, I'm Bryn Phillips. I guess I'm normally sitting in Bushra's seat and kind of talking about the data, and I'm really happy to say that I'm not having to do that this year. It's a tremendous relief in some ways, but also I feel like I'm missing out in other ways. Bushra's been churning through these data for months now, and so it's pretty exciting, the visualizations she's created, and so we're pretty stoked to show it off today. Like she said, there's a lot of good things we want to talk about and questions we want to pose and input we want to receive. So we're all looking forward to that today. Katie?
I'm Katie Siegler, and it's good to see so many familiar faces here. I've been with the SPoT program since the beginning. And I think you're really going to enjoy some of the slides that Bushra's put together today. And the discussions are always lively in these meetings, so looking forward to it. Before we begin, can we just do a round of introductions of the SRC members?
Sure. Hi, I'm Jim Orlando. I'm a hydrologist with the Pesticide Fate Research Group in the U.S. Geological Survey, and a member of the Scientific Review Committee.
Oh, sorry. Go ahead, Kelly.
Rob. Go ahead.
Okay. I'm Robert Budd. I'm a research scientist with the Department of Pesticide Regulations Surface Water Protection Program.
And I'm Kelly Moran. I'm a senior scientist at the San Francisco Estuary Institute.
Hi, I'm Ashley Parks, and I am a managing scientist at SPoT, and my background is environmental chemistry and toxicology.
Good morning, Mary Hamilton with the Central Coast Water Board. I've been with the SPoT program and SPoT program since their inception, and currently oversee standards, water quality standards, TMDLs, planning, and assessment programs, as well as our non-point source programs. So the Ag program in Region 3, which is the program that is trying to address some of our biggest problems, including pesticides and toxicity, which are very widespread in our region.
Great, thank you, everyone. I think in the interest of time, we won't go through all of the introductions. So Bushra, if you're ready, we'll pass it over to you.
Yes. Let me share my screen. Can you guys see the PowerPoint view, presenter view of the first slide?
We don't see anything.
Okay.
Tony, does she have, did you make her a co-host? We need to. There we go. We've got screen,
Okay.
but it's like a space background. There we go. Now it's.
There we go.
Okay. So everyone can see it in a full PowerPoint mode, right?
Yes.
Okay.
It looks good.
Thank you. Okay. Again, I want to thank everyone for their time and SRC members for the investment in this program. I have listed the agenda here, and I don't have times here, but I do have a clock in front of me. So somebody call me out if I'm spending too much time. Okay. So I'm going to start with this graphic. This is something that you guys have seen in the past in previous SRCs. This graphic shows, or this slide summarizes, history of the analysis that we have conducted for the program. We are in the 17th year of SPoT, and this slide has 16 years of data and analyses summarized here. So the top row lists all the years that we have been going to the sites and collecting sediment samples. For those of you who are not super familiar with SPoT, it's a sediment monitoring program where we go annually to 90 sites all across California, and we collect sediment samples, we bring them home, we conduct toxicity testing here at Granite, and then we send out samples for targeted chemistry under the statewide chemistry contract. So the top row here lists the years, below which are the number of sites that we visited for that year. The first column lists the analysis type, with toxicity listed in the first two rows. So for toxicity, we use the amphipod Hylola azteca and Mitch Coronimus dilutis. Coronimus, as you can see here, was added later in the program to capture the toxicity of some analytes that the Mitch is known to be sensitive to. And these data that we have collected over the years have been used to conduct trend analysis which utilizes temporal changes and statistically assigns a label to a series of values to indicate if there's an upward or downward trend. And as some of you know, out of the 90 SPoT sites, 40 are categorized as urban or tier 2 sites, and some analytes are historically measured at these sites. So in the first column, wherever you see urban in parentheses, these are contaminants which were only analyzed for our tier 2 sites. The red crosses indicate data which were not high quality, which were unusable due to either QA issues or elevated number of non-detects that skewed our trend analyses. And everywhere you see a black X or cross, those are the data that we have collected over the years. The most recent addition to this list of analytes is PFAS, which we started to monitor since 2021. And in the first 2 years of this data collection for PFAS, we found some QA issues. All of our data were estimated, and with Tessa's help, we got some of our burning analytical questions and QA questions resolved. And based on those conversations, we decided not to use those 2 years of data for our trend analyses. And we decided to go for higher quality laboratory. So we conducted PFAS analyses in 2023, which the data for which I'm going to show you today with the SGS Access. Okay. Can you see the next slide? Okay, there we go. So I'm gonna be showing you historical trends that are most updated through 2023. Please note that we are awaiting data for some analytes, which I will point out as we go through these trends. But really briefly, I wanna go over how we do our trend analyses. So the trend analysis is conducted using Mann-Kendall statistical method, which is a non-parametric statistical test that identifies trends over time. It is a useful tool in monitoring because it just doesn't assume how the data that you are analyzing, they are distributed. So it doesn't assume a specific distribution of data. It also doesn't assume what time, or it's not susceptible to the time period over which you're collecting the data, and it handles missing data points or irregular sampling periods and events pretty well without skewing the trends. So the method assigns a statistic to a series of sampling events by providing a score to the differences between sequential sampling events and calculating the sum of those scores. So if it calculates a score of greater than 1, that indicates an upward trend, less than 1 indicates a negative trend. Along with that statistic, it also calculates a coefficient of variation and a confidence factor. And the confidence factor further differentiates your upward or downward trends into whether they're probably increasing or probably decreasing, or based on the fact that if your confidence factor is above 90%, but below 95, it would tag that upward or downward trend as probably. And if it's above 95%, if it's positive, it will say upward. If it's negative, it will say downward. When there is very high or very low variability in the measurements over time, this confidence factor drops below 90, and the test assumes that either there is no trend or there is a stable trend. And the way it differentiates between no trend or a stable trend is based on the coefficient of variation. So if there's a lot of scatter in your endpoints that you're measuring, then it will assume a no trend. And if there is a low variability in your measurements, then it would assume a stable trend. So that's just in a nutshell how these analyses are done. So using our Mann-Kendall method, we have conducted site-specific trends and identified statewide trends. For site-specific trends, measurements over times are analyzed for each site, and these trends for each site are then used to generate percentages of sites with different trend categories. For statewide trends, we measure medians statewide annually for each analyte, and trends are identified using these medians over time. So in the following slides for different markers and different analytes, you are going to be seeing these categories represented in different colors: increasing, probably increasing, decreasing, probably decreasing, stable, and no trend. Does anyone have any questions so far before I jump into the first set of data? I can see my screen, so I'm going to take the silence as no. Okay. So the first set of data that you see here are our toxicity data. So these charts show percentages of sites with different toxicity trends indicated by different colors. The tan and the orange indicate elevated toxicity, and the greens indicate a decrease in toxicity. Toxicity trends are identified using 2 species, as I mentioned at the top of this presentation, a freshwater amphipod, Hylela esteca, and a midge, Larva Chironomus dilutis. And 2 toxicity markers were utilized for each of these species. So in the black box on the left, the first pie chart in each of these boxes show toxicity based on our mortality results, and on the right, you see toxicity based on our growth marker. So for mortality, we are measuring how many dead organisms we have at the end of a test. And for growth, we are measuring if there are decreases in growth. So decrease in growth is going to represent increases in toxicity, which is what you see here in the tan and the orange colors. So for the first box, for the Hylela, you see 4% of sites out of the 90 sites that we went to between 2008 and 2023, 4% of those sites are showing an increase in toxicity and 9% are probably increasing. So that adds up to 13%. And for Hylela, 8% of the sites were showing decreases and another 8% probably decreasing based on the mortality marker. So that's a total of 16%. So fairly comparable of what's going up, what's going down in terms of toxicity for Hylela based on mortality. For growth marker, you see about 21% of sites going up in toxicity and only 4% going down for Hylela. One thing I want to point out here is that the blue wedges that you see across all these 4 pie charts, they range between 65 to 82%, indicating that most of these trends are stable, which is represented by that dark blue color, and light blue shows no trends. We also, in our experience, we've also found that the mortality marker is less variable overall. And based on these results and based what we have collected over the years, we know that toxicity markers are excellent screening tools, and it really helps us to prioritize monitoring at the sites which look to be impacted. Statewide trends for toxicity were also identified for both of the toxicity markers for both species, and the calculated median for each site over the years was also correlated with agricultural and urban land use at a 5-kilometer radius from that site using the National Land Cover Database from 2019. Kelly, I think I see your hand up.
Yeah, I just wanted to ask that, did you also do trends for a shorter period, like after mitigation measures were implemented for either of these or for any of these, or did you only do trends for the entire period?
We have done for toxicity and for other analytes that I'm going to point out trends at different scales. But specifically with this toxicity data set, I have not recently done trend analysis right after mitigation efforts. Brent, do you have anything to add to that?
We haven't done anything. I mean, there's only been a couple of specific mitigation measures that we feel that we could capture, and one would be the labeling stuff for pyrethroids that DPR did about 10 or 12 years ago. And then the second would be, looking at copper reductions after phasing out brake pads. And we feel like the pyrethroid question's been adequately answered both in our trend analysis and in Rob Budd's paper from a few years ago. And then I think that as Bushra just said, I think we're starting to look at, she's looked at trends on different scales. I'm not sure if she's done the work with copper, like on shorter time scales, like in the last few years versus, the time scale since the beginning of the program. But that's definitely something we can look at.
Okay, so you haven't done, like, since the fipronil because some of these, the trend was up because use increased and then the use might change. So the trend might be different after that time, either because of the regulation or for some other reason for pyrethroids and fipronil. Okay, that's helpful.
Right.
So I understand better the data.
Yeah, so we could dig into that specifically. I feel like we've dug into that for pyrethroids, but probably not for fipronil. Fipronil, we've had kind of a funky data set
Yeah.
in the last few years. And we've been, I know Busher will speak to this more in a moment, but I know that we've had to sort out the data that the contract lab has done in the last few years. And we haven't been happy with it. So I think it's just been sorted most recently. Again, I'll let Busher talk about that when she gets to that slide.
Yeah, we can talk about that later. I just want to understand what I was looking at and why I was seeing what I was seeing. Thanks.
And Kelly, so in terms of timescales, for different analytes, and I'll point out wherever I have found differences based on that temporal scale. We have done different iterations of for different analytes of what makes sense, because on the temporal scale, we also have analytical variability sometimes that many times that skews the trend. So we have done all of that, but as Brent mentioned, specifically for some of these changes in like labels, we can dig further into that. But for pyrethroid, I think that has been adequately answered, but fipronil is another one that we can talk about it in detail. So I'll point that out when I get to fipronil. Okay, so the trends for statewide toxicity were identified for both markers, both species, and the median for each site over the years was also correlated with agriculture and urban land use at a 5-kilometer radius from the site using National Land Cover Database from 2019. I know the 2021 National Land Cover data are out, and we are going to be obtaining that to update some of the correlations in future. But I do want to point out that in the subsequent slides for all analytes, you will see these land use correlations, which are derived using that 5-kilometer radius delineation. So both toxicity markers for the amphipod Hyalella have significant negative correlations with urban land use. And the midge growth had significant correlations with agriculture, and the growth was seen to be increasing statewide between the periods of 2008 and 2023. When you look at this table, for toxicity, you don't see much in terms of trends or much happening. And the reason for that is that the toxicity details are always at a site-specific scale. So the devil is really in the details here. I'm going to walk you through this, this table. You have seen a version of this table all the way up to 2022. It was just a different alignment. Brent showed it horizontally. I put it in vertically, and I've divided into 2 pieces. And the only reason I've divided this table into 2 pieces is for visual convenience. So the data that you see here are based on our Hyalella mortality marker, which is the most, which is the least variable, most sensitive marker that we have right now. And it's shown here divided into 3 categories. Green is non-toxic, yellow is moderately toxic, and red is highly toxic. Sites are divided, like I said, in 2 tables and are grouped by region. So on the left, you have region 1 through 4 represented, and on the right, you have at the top region 5 through 9 represented. First column in both tables lists the site name. The last column indicates the trend. So if you don't see anything in the last column, that means there was no trend identified. Otherwise, you'll see either stable written or an upward or downward arrow. If the arrow is grayed out, that means those the trend for that site is probably increasing. So again, goes back to the confidence factor. So the gray arrows just mean that the confidence factor associated with that trend was above 90%, but below 95. The top row lists the years 2008 through 2023, and every number that you see in every cell represents percent controlled survival of this amphipod. So higher the survival, lower the toxicity, and vice versa. So high survival would be shown in green, and low numbers are shown here in red. So the point of showing this is that some sites have stayed non-toxic, as you can see throughout our 16-year monitoring, and some have stayed mostly toxic. And some sites go up and down. And there are some unexpected increases. So for example, if you look at the second table, the first site in Region 6, Bishop Creek, it was non-toxic throughout. And in 2022, it had 4% high level survival. And in 2023, it bounced back to non-toxic levels. On the other end of that spectrum is the last site listed here in Region 9, is Tuana River, which has been mostly toxic throughout the history of this program. But this past year in 2023, it showed 91% survival, 91% of controlled survival. So what these data show us is that the application of a standard toxicity marker as a tool is really critical to screen for toxicity. And there are many reasons why toxicity works so well to identify which sites are impacted. One is because toxicity is capturing everything that is in that sample, the effect of everything that these animals are getting exposed to. But two, toxicity is also robust because it is not vulnerable to the same kind of analytical variability that a lot of targeted chemistry is. So a dead Hylella is dead in 2008, and a dead Hylella is counted as dead as in 2023. So it's so we definitely want to continue doing toxicity assessments at the sites to look for impacted sites and use that as a robust screening tool. And you can do this exercise with other markers. So I've only shown you the Hylella mortality marker, but you can do it with Chronomus, you can do it with growth, and arrange your data to look at site-specific impacts in this way. Jumping on to the first analyte group. So I'm going to show you results and the statewide trends for pyrethroids first. So all the charts here. Yes.
Bushra, can I interrupt real quick? Can you go back to the previous slide?
Go ahead.
I just wanted to point out that I know there's a lot of regional swamp coordinators on this meeting today, and thanks for coming and thanks for your interest for sure. But just like there's probably, there's definitely a few rows here in these tables that are all red and yellow, and some of those sites may be in your region. And so I think it's cool to point out that, there are definitely problem sites that could beg for more intense study or maybe some actions. You guys are probably already aware of these sites, but this is something as the toxicity and contaminant program, we're very interested in thinking about digging deeper into these sites. So just as SPoT monitoring, we're going to keep going there, but as the TCP, we're also very interested in pointing these sites out to folks and seeing what other kind of actions can be made. So that's just kind of a little plug for going above and beyond in SPoT.
Rob.
Yeah. Hi. So this really interests me, especially like looking at the 2022 and 2023 data, and especially down a lot of the really toxic sites in Southern California, Biona and Bouquet Canyon. It's showing this interesting uptick or lower toxicity values. And I'm just wondering, if there's anything that could help explain some of these upticks in the last year or two data in terms of so my first question is, are all the sediments collected at the same time of year? And then also I also wanted to point out that last year and this year has been extremely wet, and there's been a lot of high rainfall and big storm events. So I didn't know if that was taken into account for possibly what we're seeing here, because I mean, the reason I know we're down in the weeds, but it kind of affects the trend analysis. So yeah, I guess those are my first two questions relating to this data.
Yeah, so some of the changes in trends for some of the sites that you see here definitely we think are connected to the storm events and the rain events. We have not done any correlations with that, but this effect of the storms and the rains are definitely being seen here. And in terms of going back to your first question, are these sediments collected at the same time? Do you mean same time every year? Are they
Like
on the
around the
cycle?
same period of time? Like if you're collecting, a bouquet at, in the spring every year, and then all of a sudden you collect one after a rain event in the fall or so forth, or does it vary a lot,
They're
or is it
collected
always
during
around
an
the same
index
time?
period. Yeah, they're collected during an index period every year. So
Yeah.
bouquet is always collected in May.
Yeah.
And so on and so forth. We follow the same pattern of collection every year. And just to address the question about rainfall, this is something that's been brought up multiple times at SRC meetings over the years of trying to capture some kind of either river stage or precipitation events in the vicinity, and it's pretty complicated. I think that maybe like you say on a site-by-site basis, we might be able to capture like discharge or flow at a particular site in a particular water body using gauging stations, but as in its entirety, the SPoT data set, it's really hard to capture something that related to precipitation that every site has, and like an accurate rainfall data, within the watershed. And I'm sure there's some ArcGIS gurus that could probably make this happen, but it's not something that we've pursued for the program.
Okay, yeah, thanks.
Peter?
Oh, just
Sorry.
one more thing. We do have notes on the site conditions when our sampling team is out collecting. And there were certainly some sites after the big rain events that had been scoured out. So we do have notes on those sites.
Peter?
All right, thank you. I just was wondering, I'm not familiar. It seems like our urban sites are maybe in region 4, and then we have region 2, it would be probably urban sites, but there seems like the Bay Area region's pretty green, pretty good. Is there I would expect urban areas in the Bay Area would have similar problems to urban areas in Southern California. Is there some sort of difference in maybe the site characteristics that are not capturing a signal, or are we or is all Kelly's work up there done a good job, and we got the municipalities got it under control up there?
There are still contaminant trends at those sites, different contaminants, but using this marker, as you can see here, we don't have much in terms of toxicity here. So there are things still increasing and decreasing at some of those sites, but the problems in region 2 are, and Bryn, just add on to that or correct me if I'm misspeaking, the region 4 and region 9 sites, they have a different soup of contaminants.
Yeah, I mean, it's pretty complicated. You're looking at what Peter's commenting on is just that, region 2 is considered pretty urban.
And
it's a lot of green, compared to like the region 4 urban or the region 9 urban. And it really is just a difference in the soup and it's urban land use, but the water bodies are different sizes. There's different volumes of water flowing through them. And again, it's a complicated issue to look at, you know, in a large regional sense. You know, the Region 2 folks, you know, they don't look at toxicity the same way as the Region 4 folks are looking at it. So we don't really have good handles other than pyrethroids. We don't really have a good handle on the absolute causes of toxicity at all of these sites. You know, it really is the soup that's creating the response in the organisms and not any one bad character. But as we've shown over the years, by and large, there are definitely generally more toxic sites in urban areas than like agricultural or open areas, and that toxicity has been in general related to pyrethroids. But we are seeing you know, toxicity at sites that don't have pyrethroids as well. So, but we're not sure what's causing that.
And I'll add to that some of the areas where we do, or some of the sites where we do have pyrethroid-driven toxicity, where we see the exceedances of thresholds, we like the sites which don't have that, just not to derail from this particular marker, toxicity marker that I'm talking about. If there are concerns, and this is like another plug, as to what we can do in terms of investigating toxicity, there can be site-specific studies to investigate a toxic signal, which goes beyond this marker, which goes beyond dead high And there are ways to capture some of those effects using different kind of tools. And some of those tools we are beginning to dig into. But if there is a specific site or a region where you think there are urban inputs, and where we know there are urban inputs, or where you'd expect toxicity and you want to investigate further the toxicity, there are ways to capture those signals which go beyond standard toxicity testing.
Yeah, thank you. I mean, it's just seems like a statewide concern to try to understand if we're seeing, I mean, I guess the problems weren't as prevalent early on there either. So there wasn't a trend of decrease in the Bay Area, but it's, you know, I mean, that's our goal to see with pyrethroid TMDLs, to see if statewide assessments can show the trend, because it's very hard to show that at a local, small municipalities are going to demonstrate the trend of improvement. So it's of interest, I think, to see what's going on there versus elsewhere. So, thank you.
I'm gonna recommend start moving on to all the trends and chemicals, just so I know we can get through all those
Yes.
in our time. But if you have other thoughts, put them in the chat, or we can save them for the rest of the discussion.
Okay. I'm gonna move on to pyrethroids. So the pie charts here include data through 2022 for 90 sites that we analyze annually. We have some data from 2023. I want to remind everyone, in 2023, we collected pyrethroid samples at 40 urban sites, but those data are not reflected in these charts because we don't have the entire set of data yet. So just to walk you through these charts real quick, bifenthrin was increasing at about 16% and probably increasing at 9%. That's 25% that you see in that first pie chart in the tan and the light orange color. And it was decreasing at a total of 9% if you add up the dark green and the light green colors. And deltamethrin was increasing, or probably increasing, at 6% of the sites. For the remaining pyrethroids, most sites show no increases. So you see these big wedges of no trends for most of these pyrethroids. Some pyrethroids were increasing at 9%, and you see in that 10 wedge, and 3% at that light orange wedge, and decreasing, and are probably decreasing at a total of 48%. But what I want to point out for some pyrethroids, along with other pyrethroids, that more than 50% of the sites out of the 90 sites that we go to showed us no trends. On a statewide scale, only delta methane was found to be increasing amongst all pyrethroids, and most pyrethroids were significantly related with percent urban land use. As presented in previous SRC meetings, we also look at pyrethroid toxic units, which are increasing statewide and are related to urban land use. The toxic unit gives you a measure of the potential of pyrethroids to cause toxicity. And we have a manuscript that we hope to submit soon in the upcoming months that is focused on pyrethroid-driven toxicity in the state. And the urban land use is also, for the pyrethroid story, is also significantly related to high Lala mortality and growth marker and correlated with some pyrethroids. So if you want to talk more about that story and that paper, reach out to me, please. So we are, like I said, we are working on putting this together as a paper to talking about the linkages between land use toxicity and these analytes. And based on these urban correlations, as well as increases in bifenthrin at some site, pyrethroid evaluations are still very important at our tier 2 sites. And we are waiting on the data from 2023 and planning to measure pyrethroids at our 40 urban sites in 2025. That will add to this data to track these changes further. Next up is fipronil. Fipronil and its degradates are measured at 40 tier 2 sites. Here you see data that span 11 years, so from 2013 to last year's season. Most sites show stable or no trends for fipronil concentrations, as you see in those big light and dark blue wedges. Fipronil is increasing at 12.5% of the sites, which is shown in that 10 color in the first pie chart. Remember, the percentages here are based on 40 sites and not 90 sites. So some fipronil is decreasing at 18% of the site, which is what you see at the bottom pie chart, and probably decreasing at 10%. So quite a few sites where total fipronil or some fipronil is decreasing. And I would note here that fipronil, as well as several other analytes, to Kelly's point early on, they change when you change the trends change when you change the temporal scale. So if you do 5 years versus 10 years, and we have done several iterations of those changes, and we have taken some of the fipronil data points that were considered suspect, and we have dug into the QA for every year, recent years, where we think some of those data should not be part of the analyses. And all of those changes, they do affect the trends due to analytical sensitivity, the data quality, and of course, environmental factors. But it is important to identify how these changes are affecting, or the temporal scale changes are affecting our overall trends. So if you look at the data from 2019 to 2023, I don't have it here. I have it in a separate slide at the end if someone wants to look at it. But the story there becomes that the blue wedges of stable and no trend, they significantly increase if you move your scale from 2013 to 2019 in the last 5 years. So overall, we definitely see a lot of sites, most sites with stable or no trends. And a lot, like only if we look at data from last 5 years, only fipronil and its sulfone were found to be increasing, and at less than 5% of sites. So overall, the story is that most sites have no trends or stable trends. Jim, I see your hand.
Yeah, just wondering, you mentioned a couple of times about data quality problems.
Yes.
I'm wondering how those, sounds like you've done a lot of work investigating some of those. I wonder how that's being documented, how that's viewable.
So first thing about data quality, I mentioned at the top of the meeting, and I should reiterate it here, that last year we chose a higher quality lab. So we went to SGS Access. So our 2023 data, after all the vetting, the QA vetting, they are robust. So using those data, we were able to close the loop on a lot of these trends reliably. In terms of documentation, I mean, we have we look through all these data and look through the QA and make a decision whether we're going to use those data in our trend analyses or not. And that's reflected in our data sheets, and I have been pointing out, and I pointed out at the beginning of the meeting where we are not using those data. But I think I am correct. Please correct me, Bryn or Tessa, in thinking that the data which have QA issues, they still go up on the database. I don't know if there's anywhere, if there are any places on the database for chemistry where it's reflected that some of those data have QA related concerns.
Yeah, I can answer that.
Yeah.
So the data are in, you can find them in CDIN, but we have a column of QA codes, which are like lab qualifiers, or our qualifiers that we add based on our secondary verification review. And then there's another column called compliance code, where we give an overall, like, do these data comply with our WAP requirements? So you may see that reflected in those data columns in there.
Thank you, Tessa.
Okay. The statewide, so moving on to the statewide fipronil trends. So with the inclusion of the 2023 data set, the statewide trends show no trends for fipronil and its degradates, except for fipronil sulfone, which was identified to be decreasing statewide. No significant correlations identified with land use. I do want to point out that inclusion of our 2023 data, which was robust high quality from SGS Access, has changed some of these trends. So the desulfonal and sulfide trends, which you saw in the last SRC, were identified to be increasing up until 2022. And like I said, we have done different iterations. We've used different iterations of this data set by removing some of those suspect numbers and then including them. But overall, with the inclusion of our most recent data, we are not seeing any correlations with land use for fipronil. Okay. Next up is PFAS. PFAS, as I mentioned, has been recently, as an analyte group, has been recently added to the list of SPoT analytes. I mentioned at the beginning that the first 2 years of these data were not the highest quality, and they had low detections across the sites and across different PFAS compounds. And this slide shows you percent detections, just to give you a comparison, a visual comparison of how many detections we had in year 1 and 2 compared to year 3, which is 2023. And the telltale sign for me for PFAS detections and the lack of good quality data was PFOS here, which is you see at the middle of this graph. That was not detected as many sites as we thought it should be detected at. And so when we dug into those data, then we realized that there were QA issues. So like I said in the beginning, the first 2 data sets from 21 and 22 would not be included in the trend analyses. We, of course, don't have enough data points right now to do a trend analysis, but what I do have to show you guys is from our 2023 data set, we have an idea of, not idea, but we have data to show PFAS contributions to overall PFAS burden. So this slide shows percent contribution to total PFAS at every site that we measured. These were only measured at our tier 2 sites. And just at a glance, what you can see here is that some PFAS compounds are more ubiquitous than others and are found across most sites. For example, the bright red here is PFOS, that's perfluorooctane sulfonate, which was detected at 35 out of 40 sites. That is no surprise to people who work with PFAS. That is the most widely detected PFAS, and basically the poster child for this analyte group. It was used before it was phased out in several manufacturing processes, and you still detect it in the sediments and in water and in organisms, and it's not going anywhere because these compounds are really, really hard to degrade, and they are very stable because of the strength of that carbon-fluorine bond. So we have a suite of 40 PFAS that include some of these compounds, legacy PFASs such as PFOS that I just pointed out, which is shown in red. as well as PFOA, which is another important legacy PFAS, shown here in that bright green, and some other carboxylics and sulfonic acid. But along with that, that suite of PFAS also includes novel or alternative PFASs that are touted as safer options, such as that bright pink you see here, which dominates 2 sites, 6-2 FTS. So overall, what these data show us that we have very complex mixtures of PFAS in sediments. And I don't know if you can tell, I love pie charts. So what I've shown here is in more data that I just described in the previous slide, I've shown here in more detail. So what I did here was that the top 3 sites with the highest total or sum PFAS that you saw on the previous slide, I've shown here in more detail. So this slide reiterates the dominance of some PFASs such as PFOS, which is shown here in red that I also pointed out in the previous slide. But there are also other concerning PFASs like that pink purplish wedge, PFDODA, that is a long carbon chain. So it has 12 carbon, highly persistent bioaccumulated PFAS, which we are seeing at some of these sites, making a huge chunk of the overall PFAS burden. So, PFAS as an analyte group, as all of you know, is a challenge. It's a beast, and the current list of PFAS, current EPA list of PFAS is increasing, continues to increase. The landscape of PFAS research and regulation is still evolving, so it's an absolutely critical analyte group to monitor, and we are going to continue to monitor it in the for the foreseeable future. And this, I must say here, that most people know PFAS as forever chemicals. So this is becoming, the DDT or the PCB of our generation, and we'll keep an eye on it. Okay, now moving to legacy contaminants. So in 2023, we measured organochlorines at 40 sites. For these sites, chlorine and DDT mostly showed either stable or no trends. And what is interesting here, and what I want to point out, that chlorine and DDT have about 85 to 90% of the sites with stable or no trends. The number of sites showing upward or downward trends are less than 5. And this is, again, based on 40 sites. But if we look at trend for all 90 sites to 2022, even larger percent sites show stable or no trends. So as I've mentioned, and we've talked about data quality in the past, the OC data quality has varied over the years. And with this year's data, we think we can close the loop on the trend story for OCs and put some of the data quality concerns to rest. And for legacy compounds, which are just like OC, which are mostly stable or show no trends, I think the answer lies in looking at these at a site-specific scale, if there is interest and funding to support those kind of analyses. But these stories have been told. We have a robust data set. We know how these trends have emerged. So we have to, in our budget, we have to make space for analytes like PFAS or analyte groups like PFAS while we finish telling these stories are about legacy compounds such as OC. So if there's interest, inputs, and feedback on organochlorine pesticides, we should discuss that today. The statewide trends for OCs identified between 2008 and 2023 for 40 sites are presented here. No statewide trends. There were significant correlations. And again, like everything else that I've presented so far, those trends are affected by analytical variability as some of these methods have evolved, some data quality issues, and we have done, again, different iterations of these analyses with 40 versus 90 sites. We have also done different temporal scales, but overall, we are not seeing much change with time in terms of these trends. So I must note here that the data slide deck that I sent out to the SRC members showed some chlorine to be increasing. And that was because the comparison that I made was included 90 sites till 2022, and 23, I only had 40 sites. So that is an important point to note here, that when we are doing these trend analyses or comparisons, our scale needs to remain the same. So that was an oversight. But with our 40 sites and the data that we have in 2023, we are seeing no trends. Similar to the OC pesticide in 2023, we measured PCBs at 40 sites. We are awaiting a full set of data. So what I have for you here is a slide with PCB trends up until 2022 for all of the 90 SPoT site. Mostly you see that big blue wedge of no trend. The statewide trend is also stable and correlated with land use. So PCBs, again, if there's interest, if there's funding, if there's feedback, we need to talk about that. We are working with Emily from Region 4 on a Region 4 PCB study. So those are the kind of studies which are important to look at PCBs at sites where we are expecting to see either trends or changes. So if your site is in that tan wedge, then we probably can investigate it further. But as a class of contaminant for all 90 sites or all 40 sites, I think some of these legacy contaminant stories are at a point that we can put them to rest, or at least put them on a cycle. PAHs, the data for PAHs, PBDs, and OPs in the next couple of slides, you've seen in previous SRC, so I'm gonna go really quickly through these. The PAHs are measured at 40 sites, and between 2018 and 2020, we had data quality issues, so we have not used them in any trend analyses. Some PAHs in the bottom pie chart were found to be increasing at 10% of the sites. And again, I want to point out that these are based on 40 sites. So that 10% of the 10% tan wedge you see in the bottom pie chart only represents 4 sites. So again, if your site is in those 4 sites, we can further talk about following PAHs or investigating further. But overall, most urban sites have no trends or stable trends for PAHs. Statewide, either stable or no trends. There were some significant relationships with the agriculture or urban land use. And for PBDEs and organophosphates, the PBDEs were measured at tier 2 sites from 2010 to 2022, no significant statewide trends. There were some sites increasing and some decreasing. And for OPs, we don't have enough data to calculate overall trends, but the trends that were seen at a few sites were stable or showed no trends. Finally, the last part of the targeted chemistry discussion are the metal trends. So the last time you saw metals was probably updated through 2020. So metals have been identified for 90 sites, and this slide shows you the trend analysis based on data from 2008 to 2022. So most sites are showing stable or no trends, but there are definitely increases. So the increasing trends for cadmium are at 7% of the sites, copper at 16, lead and nickel at 13, and zinc at 9. So of course, different metals have different levels of concerns of toxicity and these increases in trends. And like Brent mentioned at the beginning, for metals, we also need regional inputs, which we need to focus our efforts or questions about which metals are critical to track at which sites. We will be measuring metals this year and this season to further track these trends, but we definitely need feedback and input to look at what sites need to be tracked for which metals. Overall, for the statewide trends, we have cadmium and lead decreasing. Everything else was fairly stable, and most of the metals except for cadmium were related to urban land use. Lead and zinc were also related to agricultural land use. This finishes the targeted part of my targeted chemistry part of my presentation. Next up is non-targeted, but I want to pause here to see if there are any questions or anything that we want to talk about before we jump into the non-targeted analysis part of this presentation. Kelly.
Yeah, I just wanted to check in. It sounds like one of the things you're looking for feedback on is whether to continue some of this targeted analysis and what the frequency is.
Yes.
But the discussion questions didn't list which ones and what your recommendations are. So I'm just putting in a plug for when you get there to tell us a little more about that. I think I caught it, but just not entirely sure when we get to the discussion. Thanks.
Okay. Okay. I also just realized that in the agenda, we didn't build a break. So
Yeah, we
I
never
mean,
do that.
okay.
SPoT doesn't take break.
That's true. I mean, who needs a break when you can talk about data, right? Okay, so we'll continue because it's only 10. But if
Why don't
and
you
when
Maybe after
Bushra?
the NTA.
Yeah, Bushra, why don't you do a little bit of the NTA and then we can take a break.
Okay, sounds good. Okay. Next up is non-targeted analysis results. I want to jog everyone's memory of where we are, where we left this discussion. So in the past, we have discussed use of non-targeted analyses as a tool to identify contaminants that are related to toxicity and also to cast a wide net to capture analytes that we are missing in our targeted analyte list. So we have partnered with Tom Young's laboratory at UC Davis to conduct NTA on a subset of SPoT samples. So the data that I'm going to be showing today is based on 30 sediment samples from SPoT 2021 that were selected to conduct NTA. And Anna Furick from Tom's group, who is here in this meeting today, has worked really hard on identifying these linkages between the toxicity data that we generate at Granite and the features that she's identifying in the samples using her non-targeted analysis workflow. So very briefly, keep in mind that I'm not an analytical chemist. I'm going to break down the NTA and how we have used it. And Anna, jump in if I miss something. So the samples that we have from the 30 samples that from 2022 that were selected for NTA, they were extracted and analyzed using LC or GC high-res mass spec. These spectra are then aligned using a software and matched using available libraries to identify features, and correlations using Spearman correlation were drawn to link toxicity data with features that were identified in these samples. And once those features are confirmed, they can be finally quantified using commercially available standards. The graphic here on the left you have seen before, but again, I just want to quickly go over how non-target analysis it works and how it assigns confidence levels to what you are measuring or what you are identifying in a sample. So this is basically a visual of what I just described in the previous slide. NTA captures thousands of chemicals and features captured using NTA are assigned confidence levels as shown on the left. And the instrumentation and methodology that we are using here are summarized on the right. So the right, that inverted triangle at the very bottom where you see instrumentation and ionization modes, those are the LC and GC platform data that I'm going to be sharing with you today. So this is a busy slide. I'm going to walk you through it. So the first set of data from our 2021 samples that you see here are from the GC platform. And so from the very top, the total features identified were 700. And after all the thresholds were applied and library matches were conducted, 424 features were identified, out of which only 51 were found to be correlated with toxicity. I'm going to talk about the boxes at the bottom, which are which describe the features which were correlated with toxicity. But before we go there, I want to point everyone's attention to the top left of those two circles, which show total unknown features and total unknown features correlated with toxicity. Those are things that we don't know that are correlated with toxicity effects or toxic effects. And noting that correlation is not causation, I still want to make sure that we are not losing sight of the fact that there are things in that soup that we've been talking about that are correlated with toxicity that we just don't know what they are. But coming back to what we do know, the features that were correlated with toxicity, the 51 features, they're divided into 3 boxes at the bottom. The first one are the correlations that we found with mortality of Hylella. The second, middle box shows correlations with impaired growth. And the last one is no correlation. So for each box, the first column shows the category of the compound or the chemical that was identified. And then the column to the right within each box shows the number of chemicals within that category. What I do want to point out here is that in the very first box, the third row of pesticides shows bifenthrin, fipronil, and permethrin, which are correlated with mortality of Hylella. So that was interesting for us to see because with 16 years of data that we have seen bifenthrin to be a culprit and causing toxicity or being related to toxicity in urban areas. So it was encouraging and interesting to see that some of these chemicals that we are finding using our targeted analysis to be drivers of toxicity were identified in our non-targeted analysis workflow. I would also like to point out in the far right table, the very top, the first category listed here was PAHs. Fluorantine was identified. I had shown you data and overall statewide analyses. We didn't find much in terms of trends or correlations. These compounds are present as very low concentrations and are not driving any toxicity, but they were identified in non-targeted analysis workflow. Next up is the LC data. So there are the LC positive on the left and the LC negative, so 2 ionization mode. I'm not going to go into details of this slide because most of what we measure in SPoT targeted analyses is GC-related data. But I will point out that there were 98 and 147 features related with toxicity, respectively, with positive and negative LC modes. And the compounds that are listed here in these 4 boxes at the bottom, these are the correlated features with toxicity for Hylella, and there are a number of pharmaceutical and personal care products which are listed here. And I want to keep this conversation focused on SPoT and sediment, but just a quick segue. We have a collaboration with the CEC unit of the Division of Water Quality, and where we are doing some sediment and water comparisons and using NTA and targeted analyses. And some of these pharmaceutical and personal care products are on that list. So we will have data from 2023, not from here, where we can do some of those comparisons. But this is just to show that there are a lot of personal care products and pharmaceuticals which are also being seen in the sediment samples. Okay, so don't read too much into this slide. I'm going to walk you through it. This is to answer one of the questions that is often asked about the use of non-targeted analyses in SPoT. And so something that has come up in the past is that what kind of quantitation comparisons are to be expected when quantitative results from a non-targeted analysis workflow are compared to our targeted analyses. So in the following slides, I'll walk you through for such comparisons for pyrethroids and fipronil. So this slide shows all data for pyrethroid concentrations from 2021 for the 30 samples that were analyzed using targeted methods as well as using our NTA workflow. The first column lists all sites here, the top row lists pyrethroids, and the 2 columns under each pyrethroid name compares the targeted number with our non-targeted quantitation results. Cells that you see grayed out are numbers from the targeted analysis which were estimated. So we'll compare the numbers in the next few slides where it's easier to compare these numbers. But what I do want to note here that several of these sites have less than, so they have concentration less than limit of quantitation or non-detects. And that was seen both in targeted and non-targeted results. So a lot of our sites were not seeing any of these pyrethroids using either of two methods. So if you take all of those LOQs, less than LOQs and non-detects out, you can compare some of these numbers much easily. And so these two pyrethroids, the bifenthrin and sialothrin, were correlated with toxicity. And any empty cell that you see here either represent non-detects or below limit of quantitation. I've removed them so that it's easy on the eyes. What I want to point out here is that in the first table for bifenthrin, there are some really good comparisons overall, with some numbers matching incredibly closely. I know there were concerns as to what our like NTA extracts and what that quantitation would look like. So for something like Sweetwater, the very bottom in region 9, you see a targeted number to be 7.5, and the non-targeted analysis led to the quantitation for 8 with a number, with the quantified number of 8.876. So these are incredibly close. There are some where the numbers are slightly off, but they're still in the same ballpark. For sialothrin, the NTA workflow provided quantitation for several sites where the targeted results actually didn't even find any sialothrin at all. So I just want people to get a visual of these comparisons, because these data show that we can build trends based on what we find, what we quantify at the end of our non-targeted workflow for some of the chemicals that we have been interested for a long period of time, such as bifenthrin. I also want to point out here that we have a lot of standards. We have 70 standards that we are going to be using to do these comparisons if the comparisons are available at the targeted end. And these comparisons of the targeted workflow and the non-targeted workflow are an analyte by analyte question. So we have pyrethroid and fipronil available to us now, and we can reliably answer that question that you get the numbers from both of these flow which are comparable in the same ballpark. Fipronil was very interesting to compare, because the fipronil, some of these comparisons show that you have no non-detects and targeted, but you get some numbers for some of these sites using a non-target analysis workflow. So just looking at these numbers, it appears that the non-targeted analysis is as useful as targeted data set, at least to build trends. Okay, that's the summary of where we are with non-targeted. There's more to come. I have Anna Furek here with us if there are nitty-gritty analytical questions, but I want to leave this slide up before we go for a break as to what we want as a group to discuss today and what kind of feedback we are looking for in with respect to different analytes and different analyses. Okay.
So should we say like 5 minutes, everyone, for break? Or do we need a longer break?
I think 5 is fine.
Okay, we'll say back in 5.
So,
Gosh.
oh God, you didn't even record that.
Yeah, that was very important. No, we'll say it again, I'm sure.
Do I need to say it again?
I'm sure you will say that again
Yeah.
before the meeting ends.
I'm Busher talks about being a rambler, and you know, I guess I've taught her everything I know in one short year.
I think you hired me because I was a rambler.
I think rambling's the wrong word. Excitement about the science is the right one. I think you guys are really excited about this science.
We are excited about the science,
We are.
yeah.
And I think this is not a thing. I know this is the first presentation ever where I wrote notes for my slides. Like even for my defense, I never write it. I just ramble. But I know the program is so big. There's so many concerns. I didn't want to lose or miss any points that were in my head during that 45-minute period. So I wrote notes and I was reading through them. And I think that just goes on to show that there are so many complex questions and there's so much data that we have that it's important for us to like focus on energy to look at a zoomed out version of big picture. Where is the program going? What questions it is answering, and what question it has already answered and which don't need to be answered in near future again. And I think those are the feedback questions that we have. Okay.
So do you want some of the committee members to start weighing in on these questions? Is that what we're
Yes.
ready for that? So yeah, I don't know if we have to go in order of the questions or if people have thoughts they're ready to share. Let's get into it.
I've got a couple questions maybe beforehand, but I'll let Rob go first.
Oh, sorry. I'm actually not going to be addressing this question right now. I actually have a more general question going back to your slides. I think maybe you mentioned that you would be putting this data out into a paper, but I think it would be good to have some type of correlation between toxicity and some of the chemistry data, especially for like the pyrethroids and the fipronil versus hyalella and chironomus, because it gives us more of a sense of like, you know, we have the chemistry portion and we have the toxicity, but it would be good to put those together sort of, because that helps us make decisions in terms of what's important and driving, like, you know, maybe there's regional questions or a statewide question that comes out of that, but it would be good to understand if, you know, thinking about, is there a good correlation between, say, fipronil and chironomus, which, you know, we haven't generally seen on our end, but I know, you know, with the pyrethroids, we see a very good correlation between bifenthrin and hyalella toxicity. So I think it just paints a better picture and helps us decide what's important moving forward. So it's more, I guess maybe that's just more of a comment than a question, but.
Couple of things about that. So one thing that I have here on my notes for analyze that either need to go on a cycle or need to be seen on a side-by-side basis, or analytes like pyrethroids where we know that these correlations exist. There are products such as paper that you just mentioned, but one of the things that I have in my notes is we can write like fact sheets, or we can present it, we can put it in a product where those correlations and those trends can be seen and utilized by regions, by the state board, and we will be updating our sites with those. Today I just wanted to have like an overall view of the program, but there is, in every slide, there is so much more that can be presented or packaged in a way that is easy to consume and shows all those results. So this is also just a comment, but in response to your comment that we are going to be updating the sites and hoping to put out fact sheets for some of these analytes to make those relationships more obvious and usable. Jim.
Yeah, I'd just like to echo Rob's comments. I mean, it's a lot of great data, and we made that, you know, many folks have made the comment, we've got a lot of great data to look at. I think the emphasis maybe needs to be on an analysis of the data to get some useful information out of it that would benefit project managers, restoration specialists, et cetera, et cetera. And I'm just recognizing that this program has sort of a stagnant budget. I'm assuming it's going to be stagnant. Has anyone looked for opportunities to partner with outside agencies or outside folks to use this data to produce some more actionable products?
So
I think that
go ahead.
I was going to say that might be a question, you know, for some of the state board folks. We've, you know, this goes back to a comment that I know Kelly's made in the past about, you know, you guys need to find more money, you know, and it would be really great if we could expand on that. And we are starting to look into that, Jim. We're actually trying to look at partnerships where we can expand what SPoT is doing. And one of the things that Bush was going to talk about is some work that we're doing with the state board's CEC work group. And that's increasing our ability to dig a little deeper into things like bioanalytical endpoints and non-targeted analysis. And so if we can keep expanding that kind of thing, we can start working on, you know, basically having more time to think about the data than have just using the money to generate the data. Bushra's working on the pyrethroid paper. Our big correlation with toxicity is related to pyrethroids. There's not a lot of relationship between any of the observed toxicity and any of the other analyte groups. That's been addressed pretty extensively in previous SPoT reports. But we can go deeper into it again. Again, it's you know, it's sort of a time related thing, and you know, time is money. So we're trying to work on the things we're getting paid to do first and foremost. But that's a good point for us to dig a little into the comparisons between toxicity and chemistry. If any of the people on the meeting, you know, have specific analyte groups they're interested in having us make comparisons to, then please let us know.
And I'll also say this, that whatever we have presented today for each of those analytes, there's more that we have done, which doesn't reflect on the slides, but we can dig in further to create, you know, products which would be useful, as I've said before. So for all of these data, we have looked at the sites which are going up, sites which are going down, but there's a lot more that we have done that we don't have time to go in today. If we want, I can do presentations on whatever analytes people are interested in, but there's definitely opportunities within these data sets to create more products. Tessa?
Yeah, actually, I like this recommendation as well in terms of creating some sort of a analysis interpretive product, or, you know, paper, whatever it ends up being. And I actually think this is really good timing. I don't know if all the swamp coordinators and partners check their email on Friday, but we actually do have a little bit more money starting in fiscal year 24-25. And just the way our contracts are working out for that year, we aren't able to get it into our chemistry analytical contracts. So it could go into your UC Davis contract to be toward, you know, writing up more of these interpretive papers or products. So that's definitely something we should chat about in the next couple of weeks, because we're gonna be working on that.
Mary?
Tessa, thanks for sharing that. That's huge. Congratulations. That's rare when that happens.
It's a little, but it's something.
Yeah, definitely.
Exciting.
So Bren, we've asked in the past, this is regional board hat, less so than advisory committee hat, but in the past, we've asked about funding, your lab to do region-specific analyses or, report cards of the SPoT data to give us our own little report card package kind of. And in the past, I think you guys didn't really have capacity to do it, even if there was funding there. Is that something that's changed for you guys? And would that be something your lab could take on as more like for me, something that'd be really useful would be like a report card for each site that I could use and look at the site-specific trends and correlations for that site and just really dig in at the regional board level. So again, wearing my regional board hat today on this comment, but do you guys even have capacity to take on additional stuff like that at this time? Should funding be available?
Busher's staring at her screen and I'm staring at the screen and we're both looking at each other's box on the
You don't have to answer that. I don't mean to put you on the spot. I'm sorry.
I want to say yes because I want to do that and I love doing that kind of work. I would love to produce these report cards. In terms of capacity, that's a hard question to answer. I would say, and Bryn, jump in if I'm going off the rails here, but I would say should funding be available, we can do that. We can produce these. I don't know the history of what is the scope of that report card, but for each site, correlations, land use, all of that kind of all of those kind of data packaged into this one summary report, so to speak. We could do that. I am very interested in doing that should funding be available. But again, I don't know enough about the history, and Bryn can talk to that.
So in the past, I don't know if you remember, Mary, in the past, we used to have regional summaries in our written reports, and they were just real brief tables with a blurb about what was going up and what was going down. And I've talked to a couple of regional representatives about this, and that we could create something like that that's just expanded into, it's not going to be a really super like a 50-page report. It would be like a brief write-up to give you guys sort of an ongoing summary of what's going on at these sites, and to talk about what we think is going on based on our frequent visits. I think that we have the capacity to do that now. We're retooling our whole program again. We'll talk about this more during the budget slide, but we're retooling it to try to free up more of our operational capacity to think about the data as opposed to just be generating the data. And we think like we have a whole bunch of data. We kind of know what's going on with a bunch of different analyte groups. We want to put some of the funding from measuring something like PCBs into something like creating what you're talking about. We want SPoT to be providing that for the regions. I mean, I'm going to shoot myself after saying this, but we wish we could just do that for you for the price of SPoT, as opposed to the regions having to give us extra money to do that.
No,
we used to do that.
It's all good.
We used to do that as part of our normal reporting, to provide regional summaries, and it's become more and more difficult to spend time with the data, and so the part of our plan for the next few years is to shift the funding more towards thinking about the data than producing the data.
And maybe that can go on a cycle too, Brent, something like that, like every 5 years, there's a a more heavy regional site-specific output for each of the sites. That could be helpful
for the regions that want it. I know, I wrote a toxicity report for Christina Yoshida a few years ago. It's probably like 10 years ago now that I think about it, but it seems like it was a few years ago. And so we know we can do that kind of stuff. It's just a matter of creating the time.
Okay.
And I also, sorry.
I just want to get to Kelly and keep getting to our speakers.
Oh, I just wanted to offer Allie the opportunity to hop in if she's here to comment on the last thing.
Sure. Yeah. Just to say that within our office too, State Board Swamp, that we've kind of been trying hard to build up capacity to support some of that data science analysis. And for what it's worth, we've got, you know, Michelle Tang and others. And Tony, I know you've got some awesome data analysis chops too. So I think as we're building out those regional reports, if that's something that we do want to tackle, that it can be a team effort, right, with State Board Swamp too. So just offering that.
Thanks, Allie.
Sure.
So I've got a few kind of bigger picture, more general comments before tackling the specific questions, which I'm thinking we might come back to. And along the lines of this conversation, I continue to think it's really important for there to be additional funding found for this program. So I'm supportive of the idea of something short-term to pull information out of the data sets that are here, and make that in a form that's useful for managers, or, you know, sort of the kind of things you guys are talking about. But I also have noticed, I don't know how long I've been on the SRC. It's certainly been more than a decade. And the program has had the same dollar values. So the actual amount of work able to be generated by it has declined by more than probably 50% with all the financial changes that are out there. So this is really huge. This program really needs a increased and long-term funding source, because that would allow the lab to hire again. I mean, we used to have 3 full-time pretty star scientists there, and it trickled down to be a pretty small operation for a variety of reasons. And I think that's not good for the state. And I'm really worried about the stability of the program and the long-term importance of this lab and these kinds of functions for the state, which I think are actually increasing now that we have the Safer Consumer Products program. So a couple of things. The first most important thing is that I still continue to advise that the program be focused towards addressing management questions. And there's some big picture, very long-term management questions on the website. And I was just wondering what happened with it. There was an exercise to try to develop some specific management questions of a list of a manageable size. And I saw it turn into a very long list that didn't seem as focused. And I'm kind of wondering what the status of that is, and then I'll follow up.
I can bring up those questions the way they are right now on the website where we left them. I'll have to get out of this presentation first. So ignore, you saw that. Here are the management questions, and this is the graphic on the website. And the top box is where all the management questions are. And this is where we left it after the work that we did last year. And we talked about this extensively in our last SRC.
Yeah, so I think these are good questions. I think the top ones are really important. And what's kind of missing here is the ability and funding to do those analyses specific to statewide regulatory actions. So I was asking questions about, but like pyrethroids, that's kind of been done. Fipronil, maybe not completely. I don't know how much Rob hasn't published anything in a while, but I don't know what DPR is doing. There's definitely questions about copper and brake pads. There's other regulatory changes that are starting up from the Safer Consumer Products program. And it feels like there needs to be some specific focus management questions and then analyses to go with them, so that when you're giving a talk, I guess I would have expected to see the management question and what we know about the answers for each of these as part of the overarching review of the program, at least every few years that we would do that. Because we tend to lose track of our management questions. So there's really two comments in one. One is about how we approach the data analysis, and the other is the sub-management questions on the last one being really focused on specific actions and doing the analysis and timing to go with that. Of course, doing that analysis and timing requires some thinking about how you approach it. So I know we've talked about this before. I think going back to, I remember 2019 saying, gee, we should do power analysis and figure out how many samples We need before and after a change to do that and think about the design of the monitoring program to give us those before data and after data. And one of the problems with the copper data is that except for Swamp Spot, there's no program in the state that has enough before data to give us the power to use a reasonably number of samples afterwards to understand what those changes are. So I'm just asking that because I think if there's this specific regulatory action, you want to think about the design of the program for coming years, that we get both before data and after data. And maybe that doesn't mean we have to monitor for that thing every year. It's more, do we have the power to answer the question? So Bryn wants to say something before I go on.
How could you tell? I was just gonna, you saw me unmute. I was just gonna say, one thing that we're a little bit in a bubble out here on the coast, and I think that if there are specific regulatory actions that are happening, say through this Safer Consumer Products Program, then we would need to know about what they are. Like maybe we don't have our ear to the ground necessarily for what those things are. And you know, we already, you know, as we talk about, we're going to bitch and moan about not having enough time to do things, and that's one of those things that we're going to not have enough time to do is to troll through the internet to try to figure out what regulations are being made. And so one of the things we rely upon you guys for is to let us know things that we should be looking into or keeping tabs on. So if there are specific things, again, let us know what they are, and we can try to take that into consideration. You know, Peter Mertens put in an appeal earlier to say that, you know, let's keep looking at pyrethroids on this statewide level, because they're in Region 3, they're developing TMDLs for this stuff. And it is still important to look at it as a statewide question. So we know to keep checking that out. But if there is a particular product out there or chemical class that we need to be paying attention to, then we can look at that.
Brent, I was going to suggest that now that you have 17 years of data, or you're going to have 17, this program might benefit from just running some change point analyses with, you know, a minimum of 6 or 7 samples on either side of a change point, and just screen for those types of changes. But can we even identify them without knowing what the regulatory changes are?
Right, change point analyses. Okay.
Well, and I totally hear you, Brent. I actually think that the State Water Board, DTSC, you know, others need to be defining what those management questions are in that area for you. That would not be an expectation I would have for the science team to be doing that. That's the cool thing about management questions, is you get the managers to define what their questions are, and with some help from the scientists to make sure they're answerable, and then those drive the monitoring program. That works really, really well. So I'll point out from my knowledge that the 2 pesticide actions in coordination with DPR, the brake pad stuff, the compliance dates of 2021 and 2025. So there was some reduction earlier, but you know, those are kind of the big dates for before after analyses. And PFAS, there's a whole lot of management action going on PFAS compounds. So I was really glad you guys picked that as the one. Ann Cooper could probably weigh in more specifically. Maybe I should pause again and let her weigh in.
I was just going to say, we're happy to continue to stay in touch and let you know of things that are coming down the line that are relevant to the aquatic realm that might be popping up. PFAS, of course, is one of them. 6-PPD quinone is another one that's popping in my head. Non-phenol ethoxylates, although I don't know how big of a change that'll be. It'll be interesting to see. That might already be in the works, but we can continue to work with you to make sure that you've got kind of the high list of aquatic related things. Actually, TPHP is one that we're working on right now, the triphenol phosphate. I saw that on your list. That will be coming down the line in the next few years. So anyway, that's we'll definitely be happy to work with whoever would be best to work with to help guide things in any way that works. But the data, the sets that y'all are able to generate is wonderful. People are always asking us for metrics and how can we show what we're doing, and Kelly knows that very well. So this kind of information would be really great to have.
Yeah.
Yeah, and Cooper, this is kind of an aside, but it's important. And Cooper mentioned that the organophosphate ester, so they're flame retardants and plasticizers, they're also going to be in our high risk category for the Bay. So I'm expecting, along with PFAS, they're going to be pretty important. So that the second kind of big comment I've got is around the lab issues, and I guess I want to understand the status of that. I know there was a lot of changing in labs and so forth. Are we now in a place where we've got like consistent labs?
Yes. Our
Yay!
chemistry lab situation is much better and stable for years to come. So
Yay! That's absolutely, I can't thank you enough. There was this horrible period in recent years, and I understand it probably took quite a huge bureaucratic lift to make that happen. And to me, that's super important because you can't do a trends program without having the same lab. Because I've seen this over and over again. Even back in the days of the metals, there's issues between the labs, and so you see a trend not working. The Bay Regional Monitoring Program had huge problems interpreting PCB data when we switched labs. So it's a really big issue. So that's important, and it's going to be important now in the long term of the program, how you interpret the data through this period of the former water pollution control lab, this intermediate period, and now the new set of labs. And that's going to be a really big challenge for years to come. And then the third comment I have is around non-targeted analysis. I really want to hear what the other folks say, but the status of our program has been that non-targeted analysis is super interesting and nice, and the chemistry isn't good enough for trends or other kinds of really detailed work. So I was impressed to see those pyrethroid results, and that shows me the quality. I know Tom's lab and the team he's got are just the best, and I'm so excited that you guys have access to them. But I'm thinking as a long-term trends thing, at least from what I know so far, and really looking to the other science advisors, I would not recommend using non-targeted for trends analysis. So those are big picture comments. I can weigh in on other stuff when we come around to those specific questions.
Anyone else who has non-targeted analyses, concerns, issues, opinions, how those data can be used? I know it's an analyte by analyte discussion, but let's just think of bifenthrin, for example.
Question: You're not planning to replace a targeted lab analysis for, say, bifenthrin with NTA, right?
Thank you, Jim. I had the same question. I was like, wait, what?
So we are going to be doing targeted chemistry for pyrethroids in 2025. So we are not replacing for now. We are still, this is the first phase of our non-targeted assessment. So we'll have another year of like not the targeted pyrethroid data. But that is one of the discussion points, that what we are getting out of non-targeted can be used in the context of this program. I know one of the goals of non-targeted analysis is to look for new compounds, look for what should be monitored. But there is a way to quantitate at the end of that NTA flow. And I know those numbers are not likely the best that you can get out of a targeted analysis. I understand that. But those numbers that you're getting, how they can be used within the context of the program, if anyone has opinions on that, let's hear that.
Well, that totally depends on the lab. I mean,
Right.
it's kind of a misnomer to call it non-targeted at that point, because it's not, it's targeted, right?
Yeah.
And it
It's
really
the
just
targeted
depends on,
end, yeah, right.
it really just depends on the lab. And I would just stress that if you're thinking about making that switch, that you make sure that that lab, whatever lab it is, has all the QC, that it meets the QAP that this program works under. Because I know that can be very stringent, and a non-targeted workflow has got so much going on in it that maybe it's not a good fit for, depending on how detailed and how not gonna say onerous, but how detailed your QAP is and the data quality requirements.
That's a really important point, Jim. And I think a comparison of those QC elements, the spikes and the duplicates and all the things from the lab between the targeted and the non-targeted could really help it inform a decision of if we want to start using those data for trends or not. I mean, maybe they're better. I don't know.
Yeah.
Because I do
Well,
know that with the targeted analysis, there's a large percentage of data that are flagged for matrix spikes or duplicates or both, and they're not being used for things like integrated report analyses and other important uses of the data.
Bushra just showed data from Fipronil that had the targeted lab had non-detects for every single analyte, and the non-targeted analysis picked up stuff. And those non-targeted analyses had standards associated with them and some level of QA/QC. And so the NTA process picked up the Fipronil and the degradates, whereas the targeted lab came back with all non-detects.
But that could be two things though, right? That could
And
be the
so
quality
like,
of the, that could be the, sorry, that could be the quality of the instrumentation, the quality of the lab, or it could be the targeted lab has a reporting level cutoff based on their QC, that maybe the non-targeted lab has a different level, and whether that's supported and whether that's good enough for your program is a decision that you guys need to look at it. Just because they saw it
yeah,
doesn't mean it's applicable to the project.
Yeah, it's a complicated issue because we've been working on, we work with a contract lab, a statewide contract lab that then decides what lab they're either going to do the work themselves or they're going to sub out to another lab. And we're able to influence the decision on that lab, and in some cases pick the lab that they're going to choose, but it's not always as straightforward as that. And so we feel like we're moving towards a more high quality system, and it's always nice to compare apples to apples, and if you have a high quality NTA work being done and a high quality targeted work being done, and then you can compare those two things. But if you're getting a higher quality output from the NTA, and why the targeted lab isn't as high a quality, then it's difficult to just dismiss the NTA results just because they came from an NTA workflow. And so we're trying, I'm learning about this. I made some grand claims about all of this stuff a couple of years ago based on my limited understanding of it. And I'm much more, careful about what I'm saying now. But I do think that as we learn more about this, I feel like there might be a shift more towards using the NTA for trend analysis based on some of the things that the NTA laboratory people are telling me, and some of the things I've been reading about. We're not there yet, but we are laying the groundwork for thinking about it. And one of the things you saw, were the slides that Busher showed with the comparison data. And I think it's just an important thing to consider moving forward. Chad, I know you've been sitting there for a while, so.
Yeah.
So I was just gonna have a comment. I really like the going in the NTA direction combined with the toxicity work, and I think there's a big opportunity to be able to use it. I know in Southern California, there's a lot of causal assessment work going on, stream bioassessment, associated causal assessment work that's starting up and happening. Also in the estuary for sediment quality objective work, but that's a little different than this program, but kind of could inform that. So I think there's an opportunity to work with other parts of not only SWAMP, like the statewide bioassessment groups doing some causal assessment, but also entities like the Stormwater Monitoring Coalition. I think they're probably going to reach out to you at some point because One site that they are interested in doing is about 300 meters upstream from one of the SPoT sites. So it would be great to get that coordination going. So I support using the combined toxicity NTA and linking it to really the biological condition bioassessment work.
And thank you, Chad. I'll add to that, and Anna, jump in if you think the more information needs to be added there. So the quantitative part of the NTA workflow is similar to how you'll do the quantification in a targeted, with the exception of that what you have extracted from these samples casted a broad net. So you may not have extracted everything. So when we are doing these comparisons, that's why we have those 70 standards that we can compare against, and we can get these numbers. We are careful comparing these numbers and proposing that they should be used for trends. And like I said, we are in the initial phases of doing that. And the comparisons are, of course, have to be apple to apples, and we realize that. And that's why I said that a lot of these decisions have to be made based on analyte classes as to how good of a comparison you're getting between the NTA workflow, that the quantitation coming out of that versus targeted. And I would argue that the 1 year of data that we chose, we didn't choose because the lab quality was bad. That was just when the funding became available and we did it. But if you were to take any random year from SPoT analyses, and if you have QA issues, that takes those data out of our trend analyses. And because we only go out once a year and are getting these numbers, 1 year is one too many to lose that. So if trends can be built on reliably, using the numbers coming out of NTA, and like Brent said, we are not there yet, and we can find the same trends without having the absolute numbers that you get from targeted workflow. I think that would still benefit the program. And I will also finally say that the third point of the third management question listed here in the box, can the causes of toxicity and contaminant threshold exceedances be determined? It's difficult to do that always with just a list of targeted chemistry, which keeps on getting more and more expensive. I don't want to bring the budget discussion into this yet, but NTA really, and I know this is not answering the comparison quantitation question, but it really allows us to look for analytes and do other investigative studies in partnerships with people who are interested in doing those things to find out what is really driving the toxicity. We don't have an entire handle on how those every toxicity or every toxic samples, what is driving that. And that's why it's important to do these kind of exercises and bring it into the mainstream monitoring design integrated with it. Tessa?
It's still all about the QC for me though. Tessa, can you speak to that?
That's what I'd like to speak to. So yeah, I mean, I think when we started this NTA project, we were calling it a pilot project. And so I think if we want to make it a more consistent thing going into the future, Andrew Hamilton, our program manager and QA officer until that position is filled again, he and I have been talking about kind of coming up with a SWAMP method validation requirement. So I think if we wanted to move to this method more consistently or, use it into the future, we would want to have the lab demonstrate their capabilities. So we would set out those requirements and have the lab show that, so that we could kind of confirm their abilities. So I think that, to me, that would really answer, if they're meeting our needs in terms of quality and accuracy, et cetera. So on that, I think maybe that's a good place to pause on the NTA discussion and get back into some of our other monitoring plan discussion questions.
Oh, no, not yet. Okay. So back to our slide where we have these longer term, bigger picture question about frequencies of targeted analyses and toxicity assessments, and what analytes should be on a cycle, how often, where they should be measured, and what trends. And I think this ties in with how I assembled this presentation, where for something like pyrethroid and fipronil, we plan to do those analyses, targeted analyses in upcoming years, and including in addition to PFAS. But this is more for all those legacy contaminants for which I showed data, and where you saw those blue wedges of stable or no trends. What is the frequency, and what is the spatial scale at which those should be measured, and how do we really get regional inputs from people in whose regions these are still something that should be monitored. Tim?
So maybe this is more directed, that's the site-specific decisions bullet.
Mhm.
But I realize you can look at it from an analyte class perspective, but have you also looked at it from a site-specific class or a category? I see from your high level toxicity graphic with all the colors on it that there's some sites that have never shown any toxicity ever in 16 years. Why are we still sampling those? Can we just drop those and save some money that way? I mean, have we looked at it specifically along, not just overall, but for certain classes, and maybe that get into that kind of level of detail?
It's a great point. I'll bring that up when I show the design. Some of those sites which have been green throughout, and where we are not seeing much in terms of changes in analytes and changes in toxicity at all, we can put them on a cycle just to keep our eye on the pulse of the toxicity, but not do them every year. I'll bring that up like at a site-specific kind of level when I show my design. Rob?
Yeah, I was just gonna actually echo what Jim just mentioned. Is it seems to me like, since you're on a limited budget, you could just really focus in on those red pieces of the pie that for all of the, legacy, or maybe not as important, I shouldn't say not as important, but less frequently monitored chemicals, like PCBs, and just focus on the red part of those pies for where they're being detected or increasing in frequency or increasing in detections, and forget all the rest, or just put them on a much larger time cycle and focus in on where you think there might be problems, and to focus to see if there's related to any effects too in those waterways. So that's kind of how I would approach it. But I'm glad to see that the pyrethroids and fipronil will continue on an annual at all the tier 2s. I'm definitely in support of that.
I'll just throw an I agree in there.
Kelly?
I think I agree. I'm trying to basically, I'm trying to look at what the analytes are, the management questions, and figure out what do you need to address the management question for each of the analytes. And that, to me, that's the exercise that kind of needs to happen. So there's no question in my mind that the toxicity measurements are a crucial part of the program and would happen every year, the Sahalela and Chronomus. And I think it's really up to you and DPR to have conversations around the pyrethroids and fipronil in particular, and any organophosphates that DPR thinks that are still in use, that they think are interesting, and whether that's a broader scan or the frequency, and which chemicals, although once you pay for the suite, you get the suite. So that I feel like those been into that category. I think your remarks about organic chlorine chemistry remind me of Rob Budd at I think the first meeting he was at, and remarked that they were banned before he was born, and now he's a senior scientist, a high-level scientist here, and we're still monitoring for them. And I guess I'm kind of not seeing what the management question need is for those, and if there is a one, that it would be very infrequent, like once a decade. For PCBs, I know there are active management questions out there for various regions with an urban focus, so not every site. In the Bay Area, there's also a TMDL and discussions about long-term monitoring network, and actually we have some budget that we may be able to grab to do something there that I will talk to Bushra offline about that, about potentially a permanent creeks monitoring network for inputs to the Bay that would include PCBs. PAHs, again, I'm not really sure what the management question is at this point, and so I would think the frequency, if we just want to keep an eye on those, the frequency there would be very low. PDBEs, there was a change. There are still issues. I'm not super clear on that, and that's something I would think DTSC would be good to get recommendations on, whether there's need for and frequency of monitoring for PBDEs. For metals, this, at least again in urban areas, is pretty important for copper and zinc. So there's a lot of exceedances in various water quality data sets. And there's management changes occurring for sure for copper from brake pads. And I think there's some other efforts on zinc, maybe not quite so big, going on out there. I think DTSC is thinking about an effort that would be something we'd want to measure through ongoing monitoring at places that were influenced by roads. PFAS is super important, and here I would think several years of really high quality targeted data. I'd love to see the top analysis would be super useful to inform management, since there is some pretty significant CV for PFAS data in water, at least in our samples in the Bay Area, the only kind of broad set of samples I've seen for PFAS in water. I really don't have a sense for what the CVs might be on data set for PFAS and sediments. The data we've seen from both wastewater and stormwater show the kind of patterns that Bushra is showing, just kind of over big picture looking at that. I'd dearly love to be able to share those data with our team internally and talk about them, Bushra. So that's my thoughts, kind of walking through all of those. So importantly, stuff like PFAS, once we have a baseline data set, I don't know that we would need to pay for the targeted every year, but it would need to be pretty frequent as compared to other things where it, we could go out to decadal or so frequencies. So that's my thought on those questions. And I think we've talked a little bit on the other stuff. The other one I just want to mention is that I'm totally supportive of NTA partnering with toxicity testing. My concern is about the ability to use those data for chemical specific trends, which chemicals, how much, and I think you guys talked about a really solid solution for thinking that through that might entail NTA being substituted for some analyses and not others. So, and then the site-specific decisions, I really think that's a management question-related decision that needs to be formulated with the regions. Thanks.
Thanks, Kelly. Rob?
Yeah, sorry, I had a follow-up question in terms of I don't know if we're missing anything. I talked to Bryn offline about this, about the correlation that we're trying to see between fipronil and chironomus. And I'm just wondering if any thought has been given to actually expanding the species of concerns for testing to see if we are, because we are just using the two, chironomus and hyalella, and we know whenever I see hyalella toxicity, we can point the finger pretty solidly back at the pyrethroids. But I'm just wondering if there's other chemicals that we might be missing a signal because of our choice in species. So I know that's increasing your budget, but I just wanted to throw that out there to something to think about.
We haven't seen, I haven't seen, and Brent, jump in if you have seen something different than I have, but these data set, those correlations with chironomus. I mean, the chironomus growth marker is highly variable, and it doesn't correlate with fipronil like you'd expect it to, or even the survival. And in terms of adding species, of course, it increases the sensitivity of your entire toxicity assessment. But like as you have mentioned, adding that is really upping the budget for toxicity, which is already high. So I mean, there could be a discussion about replacing Coronimus if Coronimus is not providing a sensitive enough signal for any of the analytes that we are interested in. There could be discussion about changing that, but adding at this point under the current budget is very difficult.
Yeah, understood.
Jason and then Jim.
Hi, from Region 8, and I just kind of want to give a perspective of someone who works on TMDLs. And we have a TMDL for legacy pesticides, and those legacy organic chlorine pesticides. And so, you know, it's good to look at those data and see that basically those sites that are bad, from my perspective, continue to be bad, and they've been bad for the last 10 years. And so, you know, if I think about if there's a half-life of DDT, and if DDT at the time that the TMDL was written in 2007 or 2006, if there was no contribution to toxicity back then, is there still no contribution, or is the contribution the same as it was in those hotspots? Because we do have hotspots. And are those hotspot locations actually in the water bodies that have the TMDL for DDX here? So those are the kind of that I have. And I don't think that for a statewide program that would justify having you continue to measure legacy organochlorine pesticides. But those are the questions I have: is if a site has always been bad, has it always been bad because of DDX and it's not getting better, or was it never bad because of DDX, or was it bad then because of, you know, legacy pesticides and now it's bad for some other reason? So those are the management kind of questions, like in practice for me from a TMDL perspective, because, you know, I think that the legacy organochlorine pesticide TMDLs that we have right now need to be fixed. I think, you know, back in the beginning, they were based on just concentrations, just chemical concentrations, and an assumption that that was toxic. And we know that that's probably not the case now. It probably has to do with, you know, synergy and different combinations of different things. And so that needs to be rewritten. But I can see using the historical data that came from this program to kind of just doing that, you know, saying, well, we're going to write it for sediment quality objectives, something that's more integrated or something like that. That has its own problems, but, you know, I just kind of wanted to point out why organochlorine data is important to me.
Jason, do your TMDLs also require the sources, the dischargers, to do some monitoring of their own?
Yeah, they do. And we have data coming from them, and their data also shows that there's still a lot of problems. I mean, the levels are still in the hundreds in some places. You know, it was all that Tustin Basin, there was farming up there. And so all that ag sediment gets bound to sediment, ends up in the bay, Newport Bay, and it's still there. You know, it's going to be there forever. But, you know, I don't know where the location, I think the SPoT location is on campus, that Campus Drive, which is sort of down at the bottom of that catchment, and there's still DDT there. So, you know, they continue to monitor. I kind of just wanted to bring up a real situation where if you discontinue DDT monitoring or PCBs, it's not going to change anything for me. It just means that I'm going to be asking permittees to do more, and they're not doing a fantastic job as it is, the way that they set it up. So anyway, that's a real life kind of situation where these data are valuable to me, but they're not valuable enough that I would want to take money out of your whole statewide fund in order to look at it. That's all I'm going to say.
goes back to like those site-specific questions, but it also goes back to, having regional inputs and other parties who are interested in investigating and getting funding for that. And we can dig in further in our existing data set to answer some of those questions without measuring anything, and see if a site got worse. And we have done some of that. So, yeah.
Yeah, I mean, I think you have enough historical revisit data that we could come to some of those kinds of conclusions.
Right.
Like, we don't
Right.
think that it's DDT. It hasn't gotten any better. It hasn't gotten any worse. DDT is the same as it was 13 years ago. What's going on with that? So I think you have enough that if you discontinued it, it wouldn't really impact us that badly, because they measure it, the permittees measure it as part of their MS4 monitoring program. So we continue to get samples, but this would be an independent evaluation, because you know how the permittees are. They like to tell the story that they want to tell. And so to have an independent group look at some kind of historical trend analysis, correlation analysis would be useful.
This is exactly what SPoT was designed to do, honestly. And I think in the early days of SPoT, it was just a blanket analysis of all of the sites. We would just do DDT at all of the sites. And now that we're at this point in our evolution, scientifically and financially, we have you, Jason, who thinks these data are important, and maybe it's important for you at 2 or 3 SPoT sites, but it's not important at the other 87 SPoT sites.
Right.
And one of the things that we're trying to get at with an increase in funding, if you will, is if there's regions that are interested in pursuing things further at their sites, then if swamp funding can come across for us to do that work, we're going to the site anyway. And so if we can grab some of that sediment and have you pay through your Babcock contract to have DDT analyzed there, then you get that analysis for a very, very low price. It's not on SPOT's budget, but it would be on your swamp budget. Region 3 has done this a ton. They've actually had us go to additional sites in their region and do a swamp style analysis at a number of extra sites, because they're interested in or SPoT style analysis rather, they're interested in having a more expansive data set. And so if there are regions that are interested in having stuff continue at their specific sites, since SPOT's going there anyway, we can get the sample and make sure the analysis gets done. And that's the whole idea of SPoT, is this backbone of monitoring sites that are answering these regional management questions. Again, that's something that's been important to you, but it wasn't something that we were aware of. But now that we're aware of it, it's something we can focus on.
Yeah, and talking towards funding, the problem with me is I hear about these I work mostly with the permittees. And if I need more information, I write a time schedule or an investigative order or something. I go through that channel. So if I hear from Heather often will send me things like, oh, do you guys need anything to get done under this SPoT program or swamp or something? I'm like, well, I'm not the swamp coordinator, and I honestly don't have time to try to figure out, okay, what do I got to do now to get this funded? And I just don't have time to do that. So
yeah,
that's part of the problem with that, is like, okay, well, they can't pay for it, but they can't pay. Okay, well, it's easier for me to just write an investigative order and take enforcement on the permittees if they don't do what I tell them to do. You know what I mean?
Mm-hmm. Jim?
Sure. Just wanted to express my support of Rob's comments earlier on looking at Chironomys again and its effectiveness as a test organism. I know for some of the work that we've done for other projects, it's been a troublesome organism for a number of reasons. And then I also wanted to say that I'm fully supportive of NTA for the purposes for which it's designed. Absolutely, and I appreciate Tessa's solution through the the QA comments. But I would suggest that if you're going to go that route, that you work very closely with the lab to make sure that they fully understand the requirements that are going to be put upon them to fulfill those QC requirements to make sure that they understand that fully and they're on board with that. Because it's definitely going to be most likely it's going to be an extended extra cost for them. So I would just suggest that you work closely with them on that.
Thanks, Jim. And
Yeah, I was just gonna allude, Kelly talked about the DTC work, so I was just gonna follow up on that about the work that we're doing that kind of aligns with the chemicals that y'all are working on here. So zinc, we are working on zinc in tires, and that is coming up, and we'll see what happens with zinc in tires, and to what extent, yeah. Anyway, we'll see, but that is something that we are continuing to work on. PBDEs is not something that we're working on presently. If someone knows of a product that is still using PBDEs, please let us know. But as far as we're aware, there's not really a spot for us there. Copper and brake pads, y'all are aware of, and that's something that we're asked to continue to monitor and see the status and how the trends are continuing. So that's something that we're always interested in seeing. Of course, we have a lot of work on PFAS, and are of course interested to see how those trends are flowing. So that of course is always going to be interesting. The TPHP popped up, that non-targeted analysis. I mean, anytime that you can tie, like you're doing, like you showed in the NTA work, anytime that you can show there's a chemical that's in consumer product and observe toxicity to an organism, that's extremely powerful for us. We show with the 6-PPD work that we don't need 90 sites for 6-PPD. Kelly can tell me exactly how many we had, like what, 4, 5, something like that, data points of 6-PPD quinone, and we were able to move forward in regulating that in tires. So we don't need a ton of data. We just need some data showing the presence of that chemical in California and the potential for adverse impacts, in this case, to aquatic organisms. And that's enough for us to take action. So the data sets that you're generating can be really powerful for us. So, when you're seeing that NTA and you are seeing those hits associated with toxicity, and you're seeing that it's, potentially chemicals that might be used in consumer products, let us know. We're super interested in that kind of stuff. And we can then work, it gets a little complicated, but on tracing it back to specific consumer products. But for our program, it doesn't have to be a definitive tie. As long as we know the chemical is used in the product, and we know there's a pathway, which SFEI and others are doing a lot of work to try and help, communicate what that pathway is. And then we've got environmental measurements. That's enough. We don't have to, completely draw all the lines. And it's a very precautionary framework. So when you get that data, please let us know, and we'll continue to attend these meetings as well. But yeah, it's really helpful for us.
Thank
Thanks
you.
so
Yeah,
much.
we'll do that. And just on that note, I'll also say that NTA data set is also building up temporally. So we have 2021 data that I shared, the 2023 data, which was done in collaboration with CEC program, that's also there. So as those data build up, some correlations will become more robust, and some of those consumer products that you said may pop up. So we'll definitely stay in touch. I am gonna move forward because we are at 11:30, and so I'm gonna show you the plan, monitoring plan and budget, all in 2 slides, one with the chemistry and one with the toxicity. And so, I don't have to mention again and again, but I think I will say it one last time, that prices are going up. So for both chemistry and toxicity. So we presented a plan and a budget for 40 samples for 2023 in the last SRC. So the first column you see with year 23-24 is what we had shown before, and we have completed that work. Because we use SGS, some of these prices are high because of how expensive they are. So this slide lists everything that we have planned all the way to 27-28, but we are inviting feedback and input based on all of our scientific discussion today about what is important and how these data are going to be used or are already being used. I will point out that at the bottom, you have the targeted chemistry subtotals, and below that, you have the non-targeted analyses. So as I have mentioned, in 23, we had a CEC collaboration that includes 18 samples that we did for sediment as well as for water, but I'm just going to talk about sediment here. So we have data coming from that collaboration, and that collaboration is expected to move into another year of sampling and running NTA on those sediment samples, which would be year the 25-26. And you see under that column for NTA, you see 16 samples. That number is going to change based on the CEC collaboration and what we can do. So for this season, that's going to start in a couple of months. For 24-25, we are doing PFAS and metals, PFAS at urban sites, metals at all 90 sites, as I've mentioned when I was showing the data, to keep tracking those trends. And for 25-26, we have pesticides, we have pyrethroids, and fipronil, as well as PFAS listed. And so this is what we have for our design for chemistry. I'm going to talk about toxicity in a second, but I have put question marks for in the NTA row to get input, but also to hear from people what they think of this design, because this is based on the science of all the trends that I've presented. This is the best way we can use the money we have to prioritize our efforts to look at chemicals which are showing increases or decreases and chemicals which are related to toxicity. I'm going to stop there because time is of essence and let other people jump in. Kelly.
Yeah, I wish I could think of a cut to offset this, but my immediate reaction is that the metals, at least copper, is really important for the period starting, because January 21st, 2025 is the compliance deadline for copper content and brake pads. And so having it, if there's going to be an assessment of the effectiveness of that, then having pretty frequent samples after that's going to be really important. These might only need to be the tier 2 sites, so I don't see any need to do these for all of the sites, and that might be a thought for some of the other analytes that you're thinking about too, is whether you need them for all the sites or just the tier 2 sites to deal with that. So the copper phase out it's not like clean. They'll still be old brake pads on cars. And I'm not exactly sure what's going to happen with the replacement brake pad market. In California, we have an exemption, but Washington State doesn't. So the exemption allows older brake pads with higher copper formulations to be sold as replacement pads for older cars. So that could mean that the reductions aren't all that quick. But given that Washington doesn't have that exemption and most brake pad manufacturers are going to want to sell all across North America the same brake pads, I'm pretty optimistic that we're going to see a pretty major reduction starting in January. So, so my recommendation would be tier 2 sites and at least copper, even if you don't want to pay for all the rest of them, and as much as you can get. I mean, no less frequent than every 2 years, and you might want more than that.
And Kelly, you're saying you want to see that at least starting in the 2025 sampling year?
Yeah.
Or...
Yeah, so starting in the 2025 sampling year is the most important time. It would be nice to have data sooner than that, but starting in 2025 is really, that's when it's going to matter.
Mary?
Thank you. And thanks, Kelly, for that comment. I cannot help but just say that I am so shocked by these prices for the individual cost for these suites. It's shocking.
You get what you pay for, is what we have learned.
No, I know, but that's
the price of quality.
Wow.
Oh, and just by the way, a 5 metal suite like that 306 price is for a 5 metal suite for 24-25. In 25-26, that price will be $700 for a 5 metal suite. So copper by itself will probably be at least $250.
Cool.
So I'll just say, coming from a agricultural dominated region where we have very small cities comparatively, obviously the pesticides are of greatest interest to us, and OC pesticides are not that interesting to us. And so I like that they're on a lower frequency, same with the PCBs, just because we know where our problem areas are, and we know that those pesticides are not changing really where we have the problem. So I really support the lower frequency of things like that. The NTA cost seeing it this way is kind of elevates the need to look at that QC. And so I'm really happy to hear that, Tessa, you have a plan to do that. And perhaps that's something that could replace these more expensive suites for the target analysis if the QC checks out and can be validated, verified, all things each year. But yeah, metals is something that's, just not that interesting in my region, but I know statewide it's really important. So perhaps it's some of these things are those types of parameters that we can work locally and reduce frequency of both sites and some of these constituents in certain places, because it's just not driving any decision making anyway, and getting a bunch of non-detects is not that informative moving forward. So I would be interested for our region at least, or maybe at the regional level across the state, and talking about some of these suites individually and deciding if that really messes up our statewide trend analysis ability and how important that is relative to tracking trends at places where we have a potential for a trend, as opposed to just non-detect sample after sample.
Thanks, Mary. Rob.
Yeah, so I guess my first question is just to be very clear. So anywhere that there's a blank, that means that there's no planned sampling for that analyte during that year. Is that correct? All the way through, and you're planning through 27, 28. Okay, so to me, that's really sad. Obviously, everyone probably agrees with that. But I'm wondering if a better approach would be, for trend analysis, you kind of want to have that consistent, year by year analysis. And I'm wondering if you could spread it out, not necessarily do all 40, tier 2s every year for even the pyrethroids. I mean, I'd much rather have at least something planned in the 27, 28, budget, where maybe you do 30 of those samples, but not all the same 30, and do more consistent through the 5-year. So you can, you can get a pulse check throughout that 5-year cycle, versus putting all your eggs in one basket or 1 or 2 years. And same thing with the, especially for the OC pesticides and the PCBs, like we've already talked about, maybe focusing in on just a couple, regional hotspots, or, specific sites of interest where you can reduce those 40 to say 10 or less. I mean, depending on what the management questions are driving. And, I know PFAS, I like to see that that's consistent throughout, but some of the others, pyrethroids and fipronil, I think you could give some thought to, designing it a little differently to have a more consistent sampling schedule, but maybe less sites, and just sort of cycle through them in some type of fashion. So that's kind of my thought process here.
More temporal coverage than spatial.
Well, okay, now, so just to clarify, I'm not saying to give up any site in particular. I'm saying to cycle through them. So say that so you could do your 20, if you had to do 20 and 23, 24, 20 and 24, 25, and so forth. And then you could spread it out throughout the 5 years for pyrethroids and fipronil. And you might even gain an extra year if you cut back on the OCs and PCBs, to say 10 sites. You're like, OC pesticides is almost the same price as pyrethroids. And I think everyone would agree on a statewide level, they're probably not as big of a concern. So you could shuffle some of that funding up into the other categories. And maybe funding's going to change for you guys. I don't know, but I'm just saying, if this is your budget for 5 years, I would definitely want to see something at the end of that cycle, that you're doing some sampling for these high priority constituents.
I'll just jump in and clarify. For OC pesticides and PCBs, we do not have a plan to sample for those in the future. That's what we did last year. That first column, the 23, 24, that's last year. So the 24, 25 column is what we're planning to sample this year in 2024, and then going forward. So we're basically proposing to not sample for OCs or PCBs in the future.
Jim.
And so this is just the budget for analysis, right? I'm assuming the SPoT budget encompasses a lot more. And maybe it's outside of our purview to see that, but it would help us to understand where maybe some cost savings could come in. I agree with Rob. To not have anything going on in those 26, 27, 27, 28 looks pretty sad. It's hard to say.
Well,
Go ahead,
Bushra,
Tessa.
I was just gonna say, those years I think are not completely planned out. That's why there's some question marks of maybe we're considering doing more NTA in those years. And we don't have to have those completely planned out right now, but Bushra was just kind of trying to present a longer term view. So I think the 24, 25, 25, 26, that's this year and next year. And so those, we feel pretty good about those plans, but yeah, we're interested in feedback on that. And then kind of 26, 27 and beyond are more open of like, what should we do? Because the only thing we know for sure we want to do is get those 5 years of PFAS.
And exactly, and I was about to say the same thing. So this is why we are doing this so early on, to think of the program in like a longer term sense. So to 26, 27 and 27, 28, we are seeking feedback, but a lot of that also hinges on what we can do with the current NTA data. Can we address the QA/QC issue to a point that some of those data will be useful in understanding trends? So it is farther out, but definitely to your point, Rob, like point taken that we can switch the tier to break it up, but like that so I just want to say that the 26, 27, 27, 28 is still we are still trying to decide and figure out how we are going to do things. But again, coming back to the budget questions, if you add up everything, and I'll show you toxicity in the next slide, it becomes challenging to fit some of these analytes. Maybe we can get regional inputs and do some work with regional funding to answer some of those questions at that scale. Bryn.
Yeah, I want to address Jim's comment. You made a comment earlier in the presentation about, if nothing's happening at a site, let's maybe not go to it or go to it less frequently. And that's part of our plan. I can't remember what Bushra has in the next slide, which is the toxicity portion of this, but our plan for it is to actually reduce the number of sites we're going to be measuring toxicity at every year as well. Some of our toxicity measurements are going to go to a cycle at sites that have a lower interest or not as exciting perhaps, or not as interesting. And so that's going to free up money for doing additional chemistry to sort of maybe populate some of those cells in the previous slide. We do like the idea of having pyrethroids at least the 40 tier 2 sites being done every 2 years at a minimum. As Bushra said, if NTA step has the quality, then maybe we can get some of those answers through NTA and not have to go with a targeted analysis. The jury's still out on that question, so we've left those blank for now. But we are playing with this idea of reducing the number of toxicity samples as well to try to increase our chemistry budget and also increase our management budget. So again, as we previously mentioned, have more time to be thinking about data and writing about data and presenting data and communication. And so we know toxicity is expensive, but toxicity it also in large part floats our boat and allows us to come back every year and do this work. So you can see for 24, 25, we are going to all 90 sites and doing our toxicity and sampling. Bushra included that sampling cost in there because that's expensive too. You got to drive all over the place and spend nights in hotels and feed people. But But in 25 and 26, we're going to go down to 65 samples per year. And that's going to essentially reduce our laboratory workload, but hopefully it will increase our administrative workload and our management workload, where we can start, you know, reaching out more to regions, figuring out what people need, addressing, you know, specific management questions, and writing some papers and getting the communication going better.
And just to add or reiterate, I should say, Bryn already said that, but none of these prices that you have seen in these two slides include any management cost. This is just collecting the sampling, conducting the tox test, or getting the chemistry data in hand without putting any time in looking at those data. Rob.
Sorry, I've got lots of questions. But going back to the NTA, you know, proposal that you had, I'm still a little mystified by how that even will cut costs, because according to your previous slide, there's 54,000 for 16 samples, so that's comes out to $3,375 per sample, and so to me, that's higher than any of these other suites, and you could certainly, you know, increase your pyrethroids and fipronil and PFAS for that same cost as one non-target. And so the non-target to me still goes back to the answering the question of, you're trying to identify a chemical or a suite of concern that's linked to toxicity and unknown toxic endpoint. So if you're not seeing that at all your sites, then I don't really see the value of spending, you know, $3,500 per sample to answer a question that doesn't need to be answered, when you can put it more into some of your other ones that you know that there's a direct correlation. So you're talking budget now, so I'm just trying to like work with numbers of, and this is with time, and I'm assuming you said that this is with Tom's lab. So if you start making NTA into another, you know, laboratory, a commercial laboratory, those prices might jump up significantly, especially if you start adding on like the suggested QAPs and QA procedures. So I'm just a little bit cautious about going down this rabbit hole with NTA, you know, and putting all your eggs in one basket, where you might end up in a more stringent budget cycle. That's all.
But with the NTA, we are also trying to kind of hit the hot spots and get more information from about that soup than just chasing pyrethroids. Because different places, different regions in the state may have different concerns. And the overall like goal here is to understand that soup and what is important where. And there can be other investigative studies, but I would argue you still get more bang for your buck, so to speak, when you, unless you're only interested in 2 analyte classes, and you can keep monitoring and chasing those numbers, which is important in itself. But it all goes back to the bigger management questions of, can we find drivers of toxicity in the state, and the contaminant trends, and just looking at 2 classes is not going to allow us to do that adequately, I would argue.
Yeah, I'll follow through with that. I'm not saying that there's not value to NTA. For sure, there's absolute value. And when you see, like you noted, if you're chasing a hotspot or a specific investigation in a region, then it definitely can have a lot of value and come into play. I'm saying, I thought I was under the impression that you were suggesting you're replacing your entire targeted analysis with NTA, in which case I think you're going to be.
That's not true. Maybe I shouldn't have
no.
shown the last 2 columns
Okay.
in hindsight. But
I made you do that, Bush, or I made you show the last 2 columns because I wanted people to have this discussion and think about it. And to your point, Rob, you're making an excellent point. And you know, but fipronil and pyrethroids for one site is $2,000, and if we pay that, we get fipronil and pyrethroids. If we pay $3,000, we might get fipronil, some of the pyrethroids, and then potentially, you know, hundreds of other compounds that can be related to toxicity as well. So we're talking about like a multi-pronged approach here. We definitely don't want to come in and sweep targeted away in favor of non-targeted. You know, we're still in the learning phases of all of this, where, you know, we have the NTA row that you see on this chart. That's being paid for by the CEC group. That's not coming out of the SPoT budget. So far that $54,000 is going to be part of our CEC budget from you know, the CEC work group at the water board. And that's not going to be part of the SPoT budget, but we're leaving these 27, 28 and 26, 27 columns blank to try to, you know, generate conversation about what you guys think is important to analyze. And, you know, we've talked about PCBs, and, you know, Kelly ran down the list and I've written down all of her suggestions. Mary has talked about what's important for her region. You know, it'd be interesting to hear, you know, I know that for you, Rob, it's important the pesticides are obviously very important. You know, you do work for DPR. And so I think that, you know, hearing about these things is great, because we're going to throw all this stuff into the mix and try to come up with what we're going to do in 27 and 28. You know, the only thing we know that we're going to do for sure is toxicity at 65 sites and PFAS. And so, you know, we want to know what else is important to everybody. You know, it sounds like, you know, based on what Kelly said, we're gonna try to get some copper in there, you know, at least some sites. You know, we're going to create a management question, a specific management question around copper, and write up a plan for that specific management question, and say we're going to do copper at this many sites with this much frequency, and put that management question and the cost into the budget. And I think that we need to do that with everything. You know, we have we got an idea already on how to do it with PFAS. We feel like, you know, if Region 8 is able to kick in a little extra funding to do some OCs at their sites, then we can create a SPoT management question for OCs that specifically addresses, you know, what that region needs. So I think, you know, this is all just kind of like trying to flesh all of this out, you know, and we couldn't have done that if we didn't see a bunch of blank columns. Kelly?
Kelly. You
muted.
Yeah.
Sorry, I'll be quick. I think this exercise tells me that part of the answer here is punting back to the managers and establishing some priorities among these management questions. So that's one thought. The scientific thought is that I challenge the team to think about whether trends could be, at this point, given the record of data, assessed with a small number of sites that would be like indicator sites, or try to be representative sites for the rest of the state.
Absolutely.
Because I feel like you're kind of at that point, you know, we're at the opposite point for emerging contaminants. So I wouldn't recommend doing that for PFAS until you have a baseline data set. But you could take a look at the data sets and see if there's maybe a handful of states statewide that could keep the trend stuff going. So that's two thoughts for you: prioritization with managers and thinking different ways about getting to the trends question.
Sounds good.
We're definitely going in that direction. And so thank you for sort of corroborating that for us.
Thank you. I just want to keep on time, so I'm going to move forward and quickly go through the next couple of slides. But if there are more question concerns, if you want to have an offline discussion, please feel free to reach out to me and we can talk about this in further detail. Okay, I'm going to go really quickly through our presentation and collaboration. So in terms of products, we have presented in the last year at the National North America Meeting of Society of Environmental Toxicology and Chemistry. We had 3 products, and we hope we are gearing up to present more this year. I'm also encouraging everyone to present at local CTACs, the monitoring meeting, the national monitoring meeting. And so we are invested in creating these products, presenting them, we are going to be updating the site and creating fact sheets as required if they are useful products of the program. But CTAC is something which is in my blood, so you'll see this over and over again. Finally, the collaborations that we have, and I want to point out that one of our goals here is to leverage the existing network of SPoT sites, leveraging the data set that we have. So like a perfect example of that is our CEC collaboration with the Division of Water Quality folks. So we are using non-targeted analyses and bioanalytical tools to identify toxicity and contaminant linkages across matrices. So we have water and sediment samples from 2023 that we are conducting NTA on. We're also going to be doing some diagnostic bioanalytical work on that. So that would definitely that connects and links a lot of what we have talked about today with SPoT. The second collaboration listed here is our collaboration with California Department of Fish and Wildlife with Office of Spill Prevention and Response. So we are looking at renewable diesel toxicity testing using freshwater and marine organisms. And I forgot to mention at the top of this slide, we had recently rebranded, so to speak, SPoT to be TCP, because we do as a group more than SPoT. So under the toxicology and contaminants program, SPoT is a part of that program, and we are trying to collaborate with other folks to do more toxicity and contaminant trends work. We also did the Morro Bay National Estuarine Program, wet and dry season sediment and water toxicity, and we have some work with that we finished with DPR Region 3 with water toxicity testing, and with Region 9 with bite adjacent testing with estuarine sediment samples. So this is something that I wanted to put out, that we are collaborating with other folks, and that continues on to find opportunities to work with folks that leverage what we already do within SPoT and beyond. And I think I put this here to remind myself to say that I'll be updating the sites with the most updated trends, and we can add more information on our website. And so if you have ideas about how you'd like to see some of these data represented beyond what I've shown today, we have a lot more detail in within all these analyte classes, especially something like pyrethroid. So we will work on that. So that will be updated soon. And I think that was it, and I can't believe I finished in time. But thank you, everyone, for your time investment. Again, feel free to reach out to me. It was good to do this exercise to talk about SPoT in a zoomed out way, in a longer term kind of way, to see where the program is going and what we are doing currently, how it fits within the management questions and beyond. Any final thoughts, remarks?
I just want to say thanks to Tony Gill, who got the recording and is taking notes, and we'll send all that out afterward. He's our SPoT TCP coordinator for SWAMP. So thanks, Tony.
Thank you, Tony. And thanks, Tessa. Yeah.
Thanks to you, Bushra. You did a great job.
Thanks, Rob.
Yeah, awesome stuff happening here. I just hope we can, that somehow the state can figure out how to find more funding.
Yeah. Thanks. I have big shoes to fill. I know everyone is used to Bryn doing these presentation and explaining everything, in a phenomenal way. So I'll get there.
It was great. Are you kidding me?
I know.
Thank you.
Thank you so much.
It was a team effort. Thank you, everyone.
Thanks all. Bye-bye.
Yeah, bye. We'll stay in touch.
Bye-bye.